Okay, here we go. Lesson 3.5, we are going to be graphing linear equations in slope-intercept form. So what are you going to learn? You're going to learn how to find the slope of a line. You're going to use the slope-intercept form of a linear equation and then use the slopes and the y-intercepts to solve those real-world problems. So here is the core concept. Slope, M, of a non-vertical line, passes through 2 points. x1, y1, and x2, y2. It could be any 2 points on the line. The slope is the ratio of rise to run, and what that means is the change in the y coordinates to the change in the x coordinates. So here it is written, this is like your slope formula, y2 minus y1 over x2 minus x1. When the line rises from left to right, the slope is positive. When the line falls from left to right, negative. So here's your positive slope, and here's your negative slope. Okay? So yes, this is very, very, very important. I believe that it's in your book, but if it's not, you might want to write that down. All right, so to describe the slope of a line, so first we want to describe it like, is it a positive or is it a negative? The line rises from left to right, so it's positive. Now we'll pick 2 points. When they're on a graph, it's kind of awesome too, because you can actually count the change in y. So if we're going, if we're starting over here with this -3, -2. Personally, because the top number is the change in y, I would have gone up my 4 first, the 4 units. Then I would go to the right, okay? And those are both positive directions. Conversely, you could start at the point at the right, the 3, 2, and go down 4 and then back 6. So a negative over a negative, or divided by a negative divided by negative is also a positive. Okay. So again, they're kind of showing you, just make sure that you're paying attention. Like, these are color coded, so the arrows they're doing are definitely going into their ratio when they're counting. And the blue one is the change in the x, so that goes on the denominator. The red one is the change in the y. All right, so let's look at this. Oh, this is a good one too. So this kind of shows you all the different slopes. We have our positive slope, we have our negative slope, and then we have a slope of 0. The horizontal lines have a slope of 0, and the reason for that is because you have a change in y of 0. It's always the same number. And then your change in x could be any different thing, right? So 0 divided by anything is 0. Undefined for the vertical slope is because you have a fraction, we cannot have a fraction dividing by 0. And in this case, there is 0 change in x, and that is the denominator. So since dividing by 0 is undefined, therefore, so is the slope, undefined. Okay. Finding slope from a table. I like to just kind of do this. I like to look at my y for A and see how is it changing, right? From 20 to 14 is subtract 6. From 14 to 8 is subtract 6. And from 8 to 2 is subtract 6. So my change in y, that triangle is like a delta y. It's a kind of a more of a scientific notation probably. I don't know if a lot of mathematicians use it, but I definitely do. So my change in y is -6. My change in x, so you'll see me using that a lot. You're going from 4 to 7 is a +3. 7 to 10 is a +3. And 10 to 13 is a +3. So you can see that here. -6 over +3, and then simplify to -2. For B, you can see that there is no change in y, right? So the change in y is 0, so the slope is 0. And for C, when you have no change in x, you cannot divide by 0, therefore it is undefined. So we will get to calculate some. So here we go. So we are going to first describe the slope. Well, a vertical line is simply undefined. So there's really, when you see it on a graph, you do not really have to calculate it, right? Because in this case, if we did calculate it, your change in y over your change in x would be, you could do, 4 minus this negative 4, and then all over 3 minus 3, since you'll have 8 divided by 0, that's what makes it undefined. You cannot divide by 0, okay? For 2, they give us 2 points. So I'll change colors here to make it a little easier to read maybe. My change in y over my change in x. So my y coordinates, it doesn't matter which way you go. You could do, start with the negative 4 and subtract 4, but then you have to come back with the x and start with the same ordered pair that you started with in the numerator. You can't just do like negative 4 minus 4 over 3 minus the negative 1. Okay, so you always have to start with the same point, but it really doesn't matter because you're looking for the difference in the y coordinates over the difference in the x. So I'm just going to start up there at the top. So 4 minus this negative 4, and then I go back to the 3 minus negative 1. Okay, so this subtraction is like the standard in the equation because it's the difference of the coordinates. So if you have a negative and you have these double negatives, don't forget how to deal with those, right? That becomes 4 plus 4, or 8, and 3 plus 1, which is 4, and 8 divided by 4 simplifies to 2. And we forgot to note that this is actually a positive slope. Okay, that's the describing the slope first, and then calculating the slope. When I look at 3, I could describe it as a negative slope. So the value I get, because it's falling from left to right, the value I get will be a negative value. So I'll change colors here again. We've got change in y over change in x. 3 minus the negative 2 all over negative 2 minus 3 would be, so we'll have 5 over negative 5, and when you simplify that, you get a negative 1. So it is, in fact, a negative slope. So that should help you too, to double check your work. All right, moving right along. Number 4 and 5. So I do like that you are told that the points in the line or in the table represent a line. So since we know it's linear, now we just have to calculate what is the change in y, right? Well, it's plus 0 maybe? Plus 0, it's not changing, right? So our change in y is equal to 0. We're putting that over the change in x, which is going up by 1. So the change in x is 1, and this is equal to 0. So the slope equals 0. It's a horizontal line. Okay, so for 5, when we do number 5, we're going to look what's happening from, the difference here going from 11 to 3 is subtracting 8. 3 to negative 5 is subtracting 8. And negative 5 to negative 13 is subtracting 8. X is increasing by 2. Negative 1 to 1 plus 2, and 1 to 3 is plus 2. So our change in y over our change in x is equal to negative 8 over positive 2, which is equal to a negative 4. So slope is equal to a negative 4. Okay. You could also, since this is a table of x and y values, this, you have ordered pairs, and so you could pick any two ordered pairs and calculate the slope between those two ordered pairs as, y2 minus y1 over x2 minus x1 using the slope formula, and also calculate the slope correctly. Moving right along. All right, we're going to use the slope-intercept form of a linear equation. So this is important, and we kind of already did this in chapter 1 when we solved what we called a literal equation, because it's an equation with two different variables. So we want to put it as y is equal to mx plus b, where m is the slope, that's the coefficient of the x variable, and the y-intercept is the constant. So a linear equation written in this form, y is equal to 0x plus b, or y is equal to b, is called a constant function. It's a horizontal line, all right? And we kind of already identified those in another lesson. So if we look at letter A in example 3, and this was just one to watch, you don't have to write anything, y is equal to 3x minus 4. In A, you can identify m and b. So the slope is 3, and the y-intercept is a negative 4 in this case, okay? For part B, y is equal to 6.5. We have a slope of 0 because there is no slope, it's just the constant, which is the y-intercept of 6.5. And then in C, we need to rearrange this equation so that we are solving for y and putting it in slope-intercept form. So we would add 5x to both sides, but they are not like terms. So negative y is equal to 5x minus 2. Then we're dividing both sides by the negative 1 to get y is equal to negative 5x plus 2. And so we have a slope of negative 5 and a y-intercept of 2, and now it's our turn. So we want to solve for y. So we'll start by subtracting the term of x if we need to on both sides. So for y is equal to a negative 6x plus 24. We divide both sides by a positive 4, and that means everything on this side gets divided by a positive 4. So y is equal to, now negative 6 over 4 simplifies to a negative 3 over 2, and it's just probably better to keep it in the fraction form because of that rise and run, and when we start to graph them, it'll be easier if it's in the fraction form. If you want to write it as a decimal, it's not necessarily incorrect, it's just harder to graph. And then don't forget to do 24 divided by 4, which is a positive 6. So our slope, m, is equal to this coefficient of x, negative 3 over 2, and our y-intercept is the constant, which is a positive 6. Okay, number 7. It's in slope-intercept form, so we can see m, which is the slope, and b, which is the y-intercept. So we just identify them. Slope is a negative 3/4, and the y-intercept is positive 2. Okay. For 8, again, we have y is equal to 5x, but we don't have a b, right? It's almost as if there's a 0, because we wouldn't have a b, we wouldn't need to write a 0. So here's your slope, which is m, and then this becomes b, okay? So slope is equal to 5, and your y-intercept is equal to 0. All right. Moving right along. Now we are going to use the slope-intercept to graph. So if we have 2x plus y equals 2, and then we want to identify the graph. So first we write the equation in slope-intercept form. Identify or find the slope and the y-intercept. Since the y-intercept is 2, that's where it's crossing the y-axis. That is the point 0, 2. You can graph that. And then use your rise and run. So from that point, go down 2 and to the right 1. All right. Okay, linear function g models a relationship in which the dependent variable increases 3 units for every 1 unit the independent variable increases. So we are going to graph g when g, the graph of g when g is equal to 0 is 3. So we're going to identify the slope, the y-intercept, and the x-intercept. Okay, it's linear, right? There's a constant rate of change. X is going to be independent, y is going to be dependent. We're going to find the slope. So when the dependent variable increases by 3, the change in y is a positive 3. And then independent increases by 1, so the change in x is 1. So we can write that as a ratio, 3 to 1 or just 3. Then we have the y-intercept. We know that g of 0 is 3, so that's the point 0, 3. We're going to use the slope to find another point on the line. So a slope of 3 can be written as negative 3 over negative 1, or positive 3 over positive 1, right? So we're going to plot a point that is 1 unit left and 3 units down from the original. Otherwise, you could go up 3 and to the right 1. Either one will work, okay? So then you identify your slope is 3, your y-intercept is 3, and your x-intercept is negative 1. When you draw the line through the points, it will cross the x-axis, and if you're using a ruler, you should be able to see what the x-intercept is. So let's try this. So we have this linear function that's going to be f models a relationship in which the dependent variable decreases 6 units for every 3 units the independent. Remember that dependent variable is y, independent variable is x, and we can notate our slope by the change in y over the change in x. And change in y, if it's decreasing 6 units, is negative 6. Change in x is a negative 3. That gives us a slope that is equal to a positive 2. Okay? So we have this is equal to m, right? We also know that the value of the function at 0 is 4. So that gives us the y-intercept, b, is equal to 4. And it's represented by the point 0, 4. Okay. So we would start by graphing that point, 0, 4. So that's going to be up here. Okay. And then we can use our slope. So in this case, again, like maybe even this ratio, right? So we would go down 6 in the down direction because the change in y is a negative 6. And then we could go left 3. The other thing we could do is, because our slope is 2, that's equivalent to 2 over 1, right? So we could have just simplified this as 2 over 1. So when we have a slope of 2 over 1, that's the same as negative 2 over negative 1. And the reason that we would want to use the negative directions is because we're almost off the graph. So we have to understand that we have some equivalence here. So negative 2, negative 1 would be down 2 and back 1. And if we kind of, I'm going to try to continue down 2 and back 1 by doing it this way and counting several slopes, right? 1, you get several points on the line, so that when you go to draw the line, it makes it a little easier. And a straight edge is still preferred because I still can't draw a straight line. However, since we graphed several of them, right, several of the points and counted the slope, we know that we have a slope that is equal to 2. We have a y-intercept that is equal to 4, and we can also identify that the x-intercept is equal to a negative 2 because we can see the point that we counted by using the slope, okay? That should do it for this lesson. If you have any questions, be sure to write them down, ask in class, or send an email.